Electric dipole. Electric dipole is a pair of equal and opposite point charges plus q and minus q separated by a finite distance. If you observe the diagram, then in the diagram there are two opposite charges are there. One charge is plus q, another charge is minus q, and both these opposite charges are separated by a small finite distance, small d. Now these two point charges are joined together by a line, right? That line is called as axial line. So axial line is a line which is joining the 2 point charges. If I draw a line which is passing through a center of the electric dipole and which bisect the axial line in two equal parts, then that line is called as equatorial line. Now in the diagram, electric dipole moment is also given. It is denoted by small p bar equal to q into d bar, where q is the magnitude of either charge, d bar is the electric displacement vector, and as d bar is a vector quantity, p bar is also vector quantity. Direction of electric dipole movement is always from negative charge towards the positive charge. Now let us go to the next topic, which is electric dipole moment. It is denoted by symbol small p bar, and if you observe the formula for electric dipole moment, it is p bar equal to q into d bar. If you remember this formula, it is easier to define the electric dipole moment definition. So remember this formula, p bar equal to q into d bar. What about q? Q is the magnitude of the charge, and it is magnitude of a single charge because there are 2 point charges are present in the dipole, but we consider only a single charge magnitude, and d is the separation distance between the two opposite charges. So let us define electric dipole moment. It is defined as product of magnitude of either charge multiplied by separation distance between the charges, p bar equal to q into d bar. Now from that formula one can easily write SI unit of the electric dipole moment. Charge is measured in terms of coulomb and distance is measured in terms of meter. So SI unit of electric dipole moment is coulomb meter. Now let us derive expression for electric potential due to a point charge. Now first we will define point charge. What is a point charge? Now when diameter, or one can say when size of the charge is very small as compared to separation distance between the charges, then we call charges as a point charge. Now as we are going to calculate electric potential, so let us first define electric potential. It is defined as amount of work done in bringing a unit positive test charge from infinity to a required point. Now let us consider figure 8.6, and in the figure 8.6 at point O we have a plus Q charge. Point A is located at a distance small r, then N point is there, M point is there, and distance of point M from the point O is small x. Then distance between point M and point N is dx. Dx is the infinitesimal small distance. Now we have a charge which is at a infinity distance, and that charge is suppose a positive test charge, so it has its own electric field in the surrounding, in its surrounding. We have a charge plus q and it is at point o, and that charge is also positive, so it emits the electric field in the outward direction. And our test charge is also positive, it has electric field also in the outward direction, and we are moving that test charge from infinity to the point m. So what will happen, as we are moving the test charge from infinity to point m, both the electric fields interact with each other. As both the electric fields are opposite to each other, so they will repel. As both the electric fields are same, so they repel each other, so repulsion force will exist between the two charges. Now let us write electrostatic force between the charge. F is equal to 1 upon 4 pi epsilon 0 q1 q2 divided by r square. This is our in general Coulomb's law formula, right? So replace q1 by q and q2 by a unit charge because it is 1 coulomb. So q2 value is 1, our q1 value is q, and separation distance between the point O and point M is small x. So we have Coulomb's law. When test charge is at point M and separation distance between the charge q and test charge at point M is x. So F is equal to 1 upon 4 pi epsilon 0 into q divided by x square. Now if you move that test charge again from point M to point N through a small distance dx, then as both the electric fields are same, so repulsion is very large, but we are trying to move the charge from point M to the point N against direction of electric field produced by the plus q charge which is present at point O. So external force is applied on the test charge so that it will move from point M to the point N against direction of electric field produced by the charge plus q which is present at point O. So work done is there because external force is applied, and as external force is applied, distance displacement takes place dx, so work done dw is equal to minus f into dx. Now why minus sign is there, because we are moving the test charge against direction of electric field produced by the charge plus q which is present at point O. Now let us calculate total work done in displacing the unit positive charge from infinity to a point A. Now from point N we move the charge to the point A. So work done W is equal to integration minus f dx, where limits of the integration runs from infinity to small r. Now put the value of f, which is minus 1 upon 4 pi epsilon 0 q divided by x square dx as it is. Now 1 upon 4 pi epsilon 0 is a constant, q is also constant, so take it out of integration. So we have a w is equal to minus q divided by 4 pi epsilon 0. Integration runs from infinity to small r x raised to minus 2 dx. Now use rules of integration. Integration of 1 upon x square dx is minus 1 upon x, right? So let us put that value. We have w is equal to minus q divided by 4 pi epsilon 0 inside the square bracket minus 1 upon x square bracket complete, and limits runs from infinity to small r. Now let us put upper limit first minus then lower limit. So we have a q divided by 4 pi epsilon 0 inside the bracket 1 upon r minus 1 upon infinity bracket complete. 1 upon infinity is 0, so we have a w is equal to 1 upon 4 pi epsilon 0 into q upon r. So this is the work done in bringing the unit positive test charge from infinity to a point A. Now this work done is considered as electric potential due to a point charge.